Hi, this is Irv Shapiro with the DrVAX channel, and today we're going to talk about something extraordinary. We're not going to talk about a 3D printer today or a piece of woodworking machinery. We're going to talk about something very special. And even if you come to this channel normally for 3D printing tips, you're going to want to watch this whole video because it's going to open your eyes to new possibilities. The new possibilities are that we can automate those components, those 3D prints, those woodworking projects we work on with electronics. And that's all within our reach. It's within our reach because you can buy a complete computer with Wi-Fi and Bluetooth and 16 megabytes of RAM for, I don't know, anywhere from $5 to $50, depending on the model. And they're tiny. This is about 2 inches by 1 inch. This will easily fit inside that 3D printed toy you just built. Or more exciting, you can think about ways you want to improve on things you use every day. How many of you have used a Ring doorbell or a Nest doorbell, one of those automated doorbells? Well, what if I told you with just 7 components, you could build a button that when pressed will automatically send an SMS message? You could use it as a doorbell. You could use it as a button for latchkey kids. When they come home, they press their button to let you know they're home. You could use it for grandma when she wants you to call and she really has trouble nowadays dialing the cell phone or perhaps sending a text message. Think about all the possibilities if you could have a bunch of buttons and when you press them, they send messages. And then you could 3D print a beautiful case for them. So if you want to open up the possibilities of adding electronics to any project, and I'm going to show you how to do it today without writing any programs. I'm going to give you the program you need, and there are going to be many more programs like this available on this channel. Then stay tuned and let's learn something together. Now, if you're new to this channel, I publish videos at least 3 to 4 times a month, sometimes more, about how to use technology to make things. A lot on 3D printing, a little bit on woodworking. I'm now adding electronics and a bit of easy programming. So please subscribe to the channel and click on the bell so you're notified about new content. What's in our shopping list today? Well, to start with, we're going to need a FeatherS2. That's this little board here. Now, I selected this board because we're going to be able to do lots of projects with this little board. This little board, as I indicated, has Wi-Fi and Bluetooth. It can be powered by batteries or a USB-C cable. And it has about 16 megabytes of RAM on it, which is plenty of memory for small single-function programs like the ones we're going to construct. Now, in addition to that, we're going to need one of these blocks called a breadboard. Now, these blocks are rather magical. They have a whole bunch of holes in them. I'll show you a close-up picture of that. Those holes are divided into 4 sections. 2 sections that are called rails, power rails. You'll see blue lines and red lines. Sometimes it's green and red lines. Well, all the holes along those are connected together. So if I plug a jumper into any of the holes along a rail, and then I plug it in somewhere else, I'm able to connect those together. So those rails are where I put my ground and my power. Then there are sets of holes in 2 sections in the center, and they're divided by a gap. It's done that way so I can plug various devices in across that gap, like our microprocessor here. And then I have access to each of the pins on each side, and I have access to power and ground. Now, you're not going to need to learn a bunch of electrical theory or a bunch of complex programming to do this project. I'm providing you some additional background just so you can begin to build up a new set of skills. When you first get these FeatherS2 boards, they're completely flat. But to make them easier to work with, we want to have pins attached to each of these connector holes. Those are called header pins. So I'm going to put the two headers that come with them, these come in the bag, on a breadboard. I'm going to lay my Feather device on top just like that. And then I'm going to use a soldering iron to put a little bit of solder between the pad, the round circle in the board, and the pin. Now, I set my soldering iron to about 650 degrees Fahrenheit, but I also like to use very fine solder. This solder is 0.6 millimeter, and it happens to be lead-free, a little safer to use. Now, I'm not going to teach you how to solder today. There are lots of videos about soldering, and you don't need a fancy soldering iron like I have that's temperature controlled. You just need an inexpensive soldering iron with a fine tip to be able to solder these. And once again, I urge you to look up some videos about soldering if you've never done that before. Now, one thing that I do, I'm an old guy. So I have these glasses that I bought on the internet for, I don't know, they were under 20 bucks. That have magnifiers in them, so it makes it a little bit easier to see. This is the hardest part of this project. If you can insert filament in a 3D printer through a filament out detector into the extruder, into the Bowden tube, you can do this. Now, after I get the headers attached to my microcomputer, and I have it mounted on my breadboard, the next thing I'm going to need to do is download some software that we're going to use to install the software for this project onto this microprocessor board. The software we're going to use is called the Mu Editor. So head over to Code with Mu, click on the download button, select the version for your operating system, and install the software. Now, once we've installed the software, we can go ahead and connect, and I'm actually going to connect the FeatherS2 that doesn't even have any pins on it yet to our computer and begin to get a feel for how this all works. So go ahead and open up the Mu Editor. Once the Mu Editor starts, click on Mode. And the mode we want to select is Circuit Python. This editor will help you develop Python programs for a variety of devices. We're going to use this device from Adafruit, the FeatherS2, that runs a version of Python called Circuit Python. There are many, many dozens of boards that run Circuit Python, and Circuit Python is a smaller version, a slimmed down version of Python designed to run on microcomputers. And MU has special capabilities to make it easy. So I'm going to select OK. Then I'm going to take a USB-C cable and plug it into my device. Make sure you plug it in all the way. If you only get it halfway, it won't work. And you should get a red power light. You should get a green, or it's actually a yellow light on the other side blinking, saying that the Wi-Fi is working. And if your Feather has the factory installed software on it, this fancy color light in the middle is going to be changing colors over and over, and you'll see a blue light come on periodically. So this is a brand new FeatherS2, and all I did is plug it in. Now let's go back to Mu. I'm going to click on Serial here, and you'll see a window opens on the bottom. I'm going to click once into that window and hit Control-C. And you'll see that it says the code is done running, waiting for reload. if I just hit a return key, I'll get 3 angle brackets, which tells me it's in interactive Python mode. So as an example, I could say print, quote, test, quote, parentheses, hit return, and it would print test. But once again, we're not learning Python today. I just want to learn about this environment. Now, you'll notice that on here, this particular colored LED is not changing colors anymore. It's because the program's not running anymore. How do I restart it? Well, I could unplug it and plug it back in. Or I could take and hit Control D. Click into the CircuitPython console, hit Control D. You'll see it reloaded. It output some things to the display, and now the program is running again. Now, how do I get programs on and off of this device? Well, I'm going to actually read the program from this device. So I'm going to click on Load, and I'm going to click on a program called code.py. Code.py is a special program name, and that program name is the name of a program that will automatically run when you power on this device. So let's open that up here. Wow, looks a little scary, doesn't it? Well, this is a program that's blinking these various LEDs and is designed to demonstrate some capabilities of this chip. We don't need to understand this at all today. I'm going to provide you all the programs you need. I just want to show you how to reload a program onto the FeatherS2. So what I'm going to do is, see right here where it says hello from FeatherS2? I'm going to add DrVAX there. And I'm going to click Save. And what you'll see happened here is it said it did a soft reboot, it auto-loaded, and now it says hello from FeatherS2 DrVAX. So we know the program I changed is on this chip. That's how powerful CircuitPython is. And that we're going to use that capability to get our software onto this chip. Our programs are going to rely upon Python, but also some libraries, some pre-written Python programs that Adafruit built for CircuitPython. So we need to obtain those libraries and copy them onto this chip. Now, one of the most exciting things about this is that if I go to my desktop, we'll see here that this particular device is showing up like a USB drive. So I can take and copy things to this directly. So what I'm going to do is I'm going to go to circuitpython.org/libraries. And if I Googled CircuitPython libraries, it would come to this site. And I need to download the latest version of this library to my computer. Easy enough. I'm going to show it in Finder. Now I'm on a Mac, so I can just double click it, and it's going to open up a folder. Then inside that folder, you'll see there's another folder called Lib. Well, I want to take that library folder, and let's actually take and move this over like this to make this a little easier for you to see. So I want to take the library folder that I downloaded, so it was in the expanded zip file inside, and I'm going to copy it to this device. How do I do that? Well, I use whatever copy feature I have on my computer. I'm going to drag it, and there's already a library file on the device. I'm going to just replace it. Now, we're going to need one additional thing besides the FeatherS2, the breadboard, a couple wires, and a button. we're going to need a way to send SMS messages. And for that, we're going to use a service called Twilio. So head over to twilio.com and click on the option to create a new account. So it's the sign up option. Follow the instructions to sign up for a free trial account. Now, free trial accounts on Twilio have a couple limitations. The primary limitation is you can have one sending and one receiving telephone number. The sending number, the from number, is a number they provide you. So when you sign up, you select the option to obtain a number. The to number is the number you're sending it to. And so in essence, you can have a single pair of numbers that you're initially using for testing purposes. But other than that, it's completely free. Now, you'll see on the side, there is an indication that it costs money. That money actually never gets charged to your credit card. So it is a free trial account. Now, once you've signed up for that free trial account, you need to go to the dashboard. You get to the dashboard by clicking on the home item. And on that dashboard, you're going to see three things you need. You need to copy down the account SID. You can cut and paste this into a document. You need to copy down the authorization token, and you click on the show button to get that authorization token to display. And you need to copy down the telephone number you were given. Because on the program that's running on here, those three parameters are necessary to send an SMS message. Okay, now it's time to wire up this board. You have your FeatherS2 installed on the breadboard. Now, you also need to install a button on the breadboard. Now, buttons are a bit funny. You need to look at the specification for the button you're going to use to make sure you know what two legs get connected together when you press it. On this little button that I purchased from Adafruit, it ends up that pins 1 and 2 are normally closed. That means they're normally connected together all of the time. And when you press the button, pins 1 and 2 are connected to 3 or 4. So you need to make sure that when you insert your button, you insert it across the gap so that the two pins that will be connected together when you press the button are accessible. So on my button here, I'm connecting pin 2 to pin 3 when I press the button. So you've put your FeatherS2 onto the board, you've put your button on the board. Then you're going to connect pin 11, and it must be pin 11, that's what the program knows about, to one side of the button. You're going to connect the other side of the button to power. So that means when I press this button, power is going to go from this red power bus through the button to pin 11. And our program is going to look for pin 11 to be on to see power. Now I'm also going to need to connect ground on the pin to the ground bus on this device. That's the blue bus here. And the reason for that is I'm going to put a resistor between the blue bus and pin 11 also. So pin 11 is connected to the switch and it's connected to ground. Why'd I do that? Well, when you have a piece of wiring floating in the air, it might have a positive charge or a negative charge. It might have some electricity flowing through it or nothing because it's floating. Static electricity is all around. There's electricity in your body. If you want to make sure something is off, it is not charged, it does not have current, when it's not connected to power through your button, then you connect it to ground. We do that through a resistor so that the connection to ground will be harder to get to, so to speak. We'll have more resistance than the connection to power. because electricity, like water, will always flow where it's easier. So we ground the pin 11 through a resistor, and then we also connect it to one side of the switch. We connect the other side of the switch to power. And I believe that's it. So let's see here. We have 3 volts connected to our bus. We have ground connected to the bus. We have pin 11 through the resistor connected to ground. And then we have pin 11 connected to our button. That's all the wiring you need to do. Now, this might seem a little scary at first. So I've also written up these instructions and posted them as an Instructable that I'll link at the bottom of this video. So you can watch the video multiple times. You also can look at it and read step by step what you need to do. Now that we have this wired up, how do we know it's working? Well, what we're going to do is I've provided you with a program just to test the button. So before we're ready to send an SMS, let's test the button. So I'm going to unplug this other Feather from here, and we're going to plug in our wired device. And now let's go back to the MU editor, go to Serial, click into the console and hit Control-C in case anything was running, and then a couple carriage returns in case anything was running on this. In this case, because I've already used it for the full program was running on it. And now I need to find these programs. So where are these programs? Well, these programs are all in a GitHub repository. GitHub is an environment, a site where you can share programs, you can work on programs of other people. I've created a GitHub repository called CircuitPython Examples under my name, I. Shapiro, and I'll link that also below. And in there, you'll see there are a couple different things. There is a SMS Button.py program. That's the full program. And there's a Button Test.py program. That's a program just for testing this. So go over to the green icon, click on code, and for right now, just click on download zip. And we're going to do that here. Now I'm going to show that in the Finder. Double click on it. It will open up a directory, and we'll see we have a diagram in there. If we look at that, we'll see that's just a wiring diagram in a slightly different format for this example. We have the test program, and we have the full SMS program. The license is what's called an MIT license that basically just says anybody can use this, do anything they want with it, but don't hold me responsible if it burns down your house. So it's a pretty simple license. Okay, so now that we have that available, let's go back to the MU editor, and let's say load and navigate to our download folder. To the CircuitPython examples and open up FeatherS2 Button Test. And what we'll see here is a pretty short program. It's 46 lines, but about half of that are comments. So it's really pretty simple. And we're not going to go through once again and look at the details here. But what this program will do when we load it onto our Feather is it'll test that button. So how do we load something onto the Feather? Well, we double click on the tab at the top and we save it to our device. So let's navigate to the CircuitPython device and we give a name of code.py. Remember, that's a special name. So let's go ahead and save that. It says there's already a code.py on the device. That's fine. We're going to overwrite it. Now the program didn't start already because we had used a Control-C to stop the other program. So to cause it to do a soft reboot and start code.py, we're going to hit Control-D. And you'll see we have a message on the screen saying press the button. Let's press the button. And it says button pressed 1. Time to press the button again. Button pressed 2. Time to press the button again. So that's how we know we have this installed properly. That's all that program does, is test to make sure the button works. Now you'll also notice here, when we press the button, the blue LED comes on for a couple seconds. So if I hit Control-C down here, it will stop the program so it's not running anymore. Whoops. There we go. Now if I press the button, nothing displays down there because the program's not running. So now it's time to configure and run the real program and get down to the business of sending SMS messages. So I'm going to close code.py and I'm going to click on New. And the reason for that is I need to set up some configuration data for my program. And the configuration data is going to go into a special file that I'm going to call secret.py. Let me show you what's in that file. Now, when we look at this file, we'll see that it has a single, what's called a Python dictionary. Looks like JSON. So I have the name of my Wi-Fi, that's a system ID. I have the password. I have the Twilio account SID that we copied down before. I have the Twilio token, the Twilio telephone number, and then I also put in here the number that I want to send the SMS to and the message that I want to send on the SMS. So you don't have to touch the program I'm providing you. You can do all of your changes in this little configuration file. I then need to save secret.py to my device. Now, I'm not going to do that right now because I've saved one that has all the right stuff in it already to the device. So I'm just going to close that. Now, I'm going to load the actual program that we want to use. And if you remember, we downloaded that to our download folder. And it was in our examples folder. And this one's called FeatherS2 ESP32 Button.py. And we're going to open that up. Now, this program is a little bit more complex. It has, let's see here, about 260 lines of code. But once again, there's a lot of comments in here. And a copyright saying this is free of charge, you can use it. Just don't hold me responsible. And right in the program is the format of the secrets.py file that we need to create. So you actually could open this first, cut and paste that into secrets.py, and then edit it to save a bit of time. Now, if I rename this to code.py and I save it to this device, it should turn it into a program that sends SMS messages. So I'm going to double click on this tab. I'm going to need code.py. I need to change to where I'm going to save it to the CircuitPython device and click Save. There's already a code.py on the device. Why? Our test program we used to test the button. I'm going to say Replace. Because I stopped it, I need to now restart it with a Control-D. And what you'll see on the screen here is that it's displaying all of the Wi-Fi networks it can see. It's connecting to my Wi-Fi network, and it says wait for button. Let's try pressing the button. I press the button. It says fetching time from World Time API. And the reason for that is I wanted to see how fast these SMS messages are actually transmitted. So I penned the current time that I get from the internet on the end of the message, and I compare it to the time that shows up in my message, my SMS application. And it says here, SMS sent with status 201. That's a successful status. This information down here is a bunch of stuff from Twilio about how it was sent and what I would be charged and those types of things. Now let's go. We're on a Mac, so we can go to Messages. And we'll see here that we just received a message. Don't believe me? Well, watch that screen now. I'm going to press the button. There we go. It just came back. It was sent. Bam. There's our new message. So you didn't have to write any programs. You just had to learn how to load programs onto this device. Now, what if it doesn't work correctly? Well, if it doesn't work correctly, you will see an error message here on the screen. So those error messages will give you an idea of what to look for. 9 times out of 10, it won't work correctly if you made a mistake in secrets.py. Most common issue. You put in the wrong network name, or you put in the wrong password. Or you put in the wrong Twilio information. You want to verify that Twilio is working? Well, you go back to Twilio and click on over here, Usage. Click on your Twilio account and click on Go to SMS Logs. And you can see here all of the messages that you transmitted. So folks, I know this looks a little scary at first, but there's 7 components total. How remarkable is that? The total cost of this, I don't know, is around probably $50. There are less expensive Wi-Fi enabled boards that we could use instead of like $25 for one that supports the battery and has Bluetooth. We could get one that's just Wi-Fi for probably half that or less. If you were producing these in an industrial setting, obviously you wouldn't use a breadboard. You would solder these wires all together and you could make it very, very small. But the concepts are really rather remarkable. So if you like this stuff, or you like to learn about 3D printing, or you like to learn about making things or lasers or other technologies, please subscribe to the channel. Forum.drvax.com has some kind, really caring and helpful people that will help you with your projects. I'm going to include a link to the Instructables tutorial, which is step-by-step below. Thanks so much. Please subscribe, click on the bell, recommend the channel, and let's continue to learn things together.